Hello, so in today's video, we're going to solve this equation there. So it looks horrible. Yeah, we've got this trig equation and we want to solve this between x being minus pi over 2 up to pi over 2. So in your A-level exams, I mean, I highly doubt you're going to get something this ridiculous. I mean, you could be asked a step-by-step question where they break down the question into multiple parts and they could lead to something similar to this, but not as long and ridiculous as this. So you won't be asked. I mean, I'm 99% sure you won't be asked something like this in the exam, but you will be expected to know how I do this. I mean, everything that we do to solve this equation here is not beyond A-level material, so it's all stuff that we've looked at before in previous videos. So there's nothing in the methods that I will use that will be alien to you, because as long as you know your identities and how to solve trig equations, we should be able to solve this one here. So that's what we're going to try and do today. So there's many ways you could tackle an equation like this. The first thing, it's just really what you notice first in terms of which identities to kind of use to simplify what we have. So the first thing that I notice here is this sine of 2x there. So what I'm going to try and do is use an identity to try and rewrite this sine of 2x there. So that's kind of going to be my step one. So if we go to the next page, I've written out my step one here. So we're going to remember our double angle formula for sine of 2x. Remember that sine of 2x equals 2 times sine x times cos x. So that's our double angle identity. So if you've not seen the double angle video that I've done on proving double angle identities, and I recommend you see that, because otherwise we can't do this question. So we know that sine 2x is that. So what you've actually got is, yeah, this here being 2 sine x times cos x. And also what I notice here is you've got sine x cos x here. So actually what we can say is if we divide this equation up here by 2 on both sides, let's just do this here. So divide by 2 on both sides, you get half sine 2x is equal to sine x cos x. So what we can actually say then is that this here must be equal to a half of sine 2x. So what we're going to get is sine 2x, so sine 2x is equal to a half of sine 2x, a half sine 2x there. And then times by, I've just called all of these terms here star, just because I can't be bothered to write out all that again. So sine 2x equals a half times sine 2x times by star. So you may be tempted at this stage to say, okay, well, let's just cancel out that and that. However, that would be wrong, because if you do that, you lose solutions, and you'll see why in a minute. So what we need to actually do is actually rearrange this to the other side. So we're going to take away this right-hand side from both sides. So we get sine 2x, take away a half times sine 2x times by this star is equal to 0. So again, the reason why I'm doing this is because if we do cancel out this and this, we lose solutions. We lose the possibility of sine 2x being equal to 0, because if we actually now factorize this equation here, we get sine 2x. Actually, what I'm going to do before I do that, just to get rid of this half here, I'm just going to multiply everything by 2 to get rid of this factor of a half here. So we're going to get 2 sine 2x, take away sine 2x, multiplied by this big thing here, multiplied by star, is going to be equal to 0. So now then what I can do is factorize out the sine 2x on the left-hand side. So sine 2x, factoring that out, and then times by 2, because you got 2 sine x there, and then take away this star there, equals 0. So what we see here in this first step is that we've got two possibilities. So either this is equal to 0, because you've got a number times a number equals 0. So either this equals 0, or this in here equals 0. So therefore we can say that sine 2x equals 0, or we can say that 2 minus star equals 0. So in other words, what this would suggest here, this second equation, is that 2 is equal to star. So we know that the number 2 equals star there. So we just make a note of that. Okay, so we've got all that then so far. I'll just put a box around this and a box around this, because these equations will be helpful. So now let's look at what we can do next then. So we've got essentially the number 2. So what we've worked out is that, yeah, so you've got sine 2x equals 0. And we've got the number 2 is equal to this in here. So I'll just put 2 there is equal to cosec squared x plus 2 cos squared minus cot squared minus cos 2x and then minus 3 sec squared x. So we can, obviously we've got equation 1 and equation 2 there. Actually, I call them A and B just because I put 1 there, step 1. So the red being step 1, the blue here is the 2 equations we get. So, I mean, we could solve this first equation straight away, actually. But I'll just leave it to the end. We'll do this first equation at the end, but we'll deal with this second equation, this hard equation here now. So how are we going to deal with this? So you got a cos squared, we got cosec squared, we got a cos squared, minus cot squared, minus cos 2x, so a double angle, and minus 3 sec squared x. So how could we deal with this? So again, it's up to you really which thing you do first, which step you take first. But what I notice is that we have this cos 2x here, this cos 2x there. So I'm going to think about my double angle formula for cos, my cos 2x formula. So that's going to be my step 2. So remember that cos 2x equals cos squared, take away sine squared. And remember, we can also rewrite this as well. We can write it as 2 cos squared, take away 1. And we can also write it as 1, take away 2 sine squared. So there's a couple of ways in which we can write this formula. So if we just copy out this equation that we got, this B equation. So the equation for B, sorry, I've gone too far. The equation for B was this here. So equation B was that 2 is equal to cosec squared x, and then plus plus 2 cos squared plus 2 cos squared x, and then minus cot squared, so cot squared x minus cos 2x minus 3 sec squared x. So that was our equation. So we're gonna like get rid of this or eliminate this cos 2x here. Now we're gonna use either this identity, or this one, and we've got to pick which one would be suitable in this case to kind of cancel terms out. And what I'm going to do is I'm going to pick this one here. So this is really the one that I want to pick. And the reason why I want to pick this one is because I notice we've got a 2 cos squared here. So when we do 2 cos squared, take away this here, the 2 cos squareds would actually just cancel out. So what we can just write now is that we've got 2 is equal to 2, cosec squared x plus 2 cos squared x, take away cot squared x, and then minus, we're going to use this identity here. So put this in square brackets just to emphasize. So minus 2 cos squared x minus 1, and then subtract 3 sec squared x, if I can fit that in there. So then, as I said, yeah, so what will happen is the 2 cos squared there, take away this cos squared, will just cancel out. So you're going to be left with 2 is equal to cosec, cosec squared x, and then minus the cot squared x, and then minus 1. Well, minus 1 is going to give you plus 1, and then minus 3 sec squared x at the end there. So we get that, and we can actually just take away 1 from both sides. So if we do that, we get 1 is equal to cosec squared x minus cot squared x, and then minus 3 sec squared x. Okay, so we get that there. So I'll call this equation that we get down here equation C. So yeah, equation C there. So what we've determined is that this equation B gives us this equation C. So 1 is equal to cosec squared x, take away cot squared x, and then minus 3 sec squared x. So we get this equation C here. So again, we've still got equation A, which we need to solve in a minute. And now we've got this equation C. So how could we solve this equation C? What could we do to further simplify this equation? So notice that we can, notice that we've got a cosec squared here, and notice we've got a cot squared. Can we think of an identity that uses both cosec squared and cot squared? So yes, we can. If you do remember what we did in the proving identities video, is that we have this identity here. So 1 plus cot squared is equal to sorry, I've done this wrong. So this should be cosec squared here. So my bad. Let me redo this. So 1 plus cot squared is equal to cosec squared. So that was one of our key identities that we proved. So if we look at this here, we've got cosec squared take away cot squared, and we've got a 1 there. So what we know then, if we just take away cot squared from both sides, is that we've got 1 is equal to cosec squared x take away cot squared x. So therefore, this cosec squared take away this cot squared is just going to give us 1. So therefore, 1 equals cosec squared x take away cot squared x minus 3 sec squared x. Well, that's just going to give us a number 1 here. This equals 1. So we get 1 is equal to 1 minus 3 sec squared x. The 1's just cancel out. So you get 0 is equal to minus 3 sec squared x. So in other words, if you just add the 3 sec squared x to both sides, 3 sec squared x is equal to 0. So therefore, yeah, we get that result there just by manipulating that identity. So therefore then, we've got this result here that, yeah, so 3 sec squared equals 0. So that means that 3, so if we use, again, the fact that sec is 1 over cos, so this is just 3 over cos squared. So 3 over cos squared x is equal to 0. So we get that result there. So what would that tell us? So what we notice then is that we can't have this equation to work because 3 divided by a number can never be equal to 0 because it's impossible. If you pick a positive number, divide it by any number, it's impossible to get 0. So actually this tells us that there are no solutions for this equation here. So no solutions for this equation C. So equation C. This one that we got down here, there are no solutions for that. So actually, there are no solutions with this second part of the equation here, this 2 equals star. There are no solutions for that. So the only equation that's going to give rise to solutions is this one here. So this sine 2x equals 0. So therefore, what we can say is therefore sine 2x equals 0. That's going to be our only set of solutions because we get no solutions from this thing here. I mean, if this is equal to a number like 1, like a positive number, then perhaps there could be solutions. But in this case, there aren't going to be any solutions because you can't get a 0 there. So yeah, I mean, for example, if this number there was a number 4, then there would be solutions. But because you got a 0 there, it's impossible to do a 3 divided by a number to give you 0. So we've only got this equation here. Again, this is the part A equation from back here, this first equation there, which gave us solutions. So taking sine inverse of both sides, 2x is going to be sine inverse of 0. That means that 2x is going to be equal to 0. Now, is that in our domain of values that we need in the solution? So x has to be between minus pi over 2 and pi over 2. So yes, it will be. So remember, if you've got x between minus pi over 2 and pi over 2, then that means that 2x has to be between minus pi and pi. So yeah, so 2x, so 0 is between minus pi and pi, obviously. So therefore, this will be one solution there. So you're going to get one possible solution here. Now let's think about our sine graph. So sketching a sine graph, so you got a sine function there. Sketching that between minus pi and pi looks something like this. You got minus pi there, you got pi there. So when does 2x equals, when does sine equal 0 between minus pi and pi? Well, actually, we can see that we get 3 solutions. Obviously, we've got x equals 0 there. We've also got x equals minus pi. That would be a possible solution. And also this one here, x equals pi. That would be another solution. So therefore, we're going to get 3 solutions. So 2x equals 0, 2x equals minus pi, and 2x equals pi. So therefore, we're going to have 3 values of x. So therefore, x equals 0, x equals minus pi over 2, and x equals pi over 2. So that would be the three solutions that solve this equation. So this equation that we started off with back here. So solutions, x equals 0, x equals minus pi over 2, and x equals pi over 2. So yeah, that would solve the equation. So that was just a demonstration of how we can actually use all the identities that we've learned to try and simplify an equation and then proceed to solve it. So any questions, just leave them in the comment section. But hopefully, yeah, that will make sense. And again, that was just a video to describe how you can actually combine multiple identities to solve these trig equations.